Hello, Hazan. This is my video response assignments regarding the topics of aggregates and concrete. I started out my learning experience by getting a brief idea about aggregates. Well, aggregates is the natural or artificial inorganic granular materials which are used to form cement, mortar, or concrete. I also learned some of the benefits of aggregates, being economical benefits as well as decreasing the shrinkage and cracking potential of concrete, as well as contributing to the strength and abrasion resistance of concrete. After that, I learned some of the main properties of aggregates, being the gradation, the maximum aggregate size, the moisture content, the unit weight, and the specific gravity. After finishing from the properties and the advantages of aggregates, I went on to learning the main classifications of aggregates, how to classify aggregates, let's say. The main one being the source, the specific gravity or weight, unit weight, the size of particles, and surface texture. The source can be divided into two parts. These are the natural aggregates or the artificial aggregates, while the unit weight can be divided into three different categories. The first one being normal weight, light weight, and heavy weight. I also learned each one of these numbers specifically. Then the sizes can be divided into two parts, being the fine aggregates and the coarse aggregates, where according to the ASTM specification, fine aggregates are smaller than 0.25 millimeters, and the coarse aggregates are bigger than 4 millimeters in size. Furthermore, I went on to understanding the importance of sampling in aggregates, and the size of sampling required is twice the maximum size of the aggregates. I also learned how to reduce the samples of aggregates by using the following two methods. The first method being the quartering method, and the second method is the splitting method. I went on to details about each of these methods and learning how to use these methods. Furthermore, I went on to understand the importance of gradation, which is the particle size distribution in a batch of aggregates. The more of different sizes of groups of aggregates, the better the aggregates, the more compact it is. Therefore, it's more durable, and it reduces any kind of cracking or abrasion. I also learned how to measure these gradations of particles in an aggregate sample, which is done by a test or an analysis named the sieve analysis. I learned the application of this analysis and how to implement this test, as well as how to obtain the different data of this test. Furthermore, after finishing from the learning the gradation and its test, I learned the ASTM limit gradation values for the respectively for the fine aggregates and for the coarse aggregates. After that, I went on to understand what is fineness modulus and its respective formula, which is the cumulative retained on standard sieves divided by 100, the cumulative percentage. And then I understood the importance of maximum aggregate size. These importance or these advantages can be such as the water requirement, the cement requirement decreases, as well as the water requirement decreases, as well as improving the workability of the aggregates. Furthermore, I went on to understand and learn the four different types of moisture state in an aggregate, these being the oven dry, the air dry, the wet or damp state, and the saturated and surface dry state. I learned the respective, I went on to details about each one of these moisture states and learn about the absorbing capacity, about the moisture state, as well as after finishing from the moisture state of aggregates and learn the absorption states, absorption capacity. I went on to understand about the specific gravity and the unit weight of aggregates. Unit weight refers to the weight of aggregates filling up a unit volume, where it's the volume of the aggregate particles packed together. This is including the solid volume of the particles, but also the space between the particles, where the specific gravity does not include the space between the particles. I learned the respective formulas of the specific gravity and unit weight, and also learned the formulas of each moisture state of the unit weight of the specific gravity. After learning the formulas of the specific gravities and the unit weight, I went on to get a brief idea about soundness of aggregates. Well, soundness of aggregates is defined as the freedom of a solid from cracks or any other flaws. And this can soundness can be is the resist also can be defined as the resistance of destructive agencies, these being the freezing, the wetting, or the heating and cooling. I went on to details about each one of these destructive physical variations and learn how the soundness of aggregates can be tested. Furthermore, When chemical reactive components are frequently found in the aggregates, expansion and cracking can occur in the hardened concrete, as well as when the reactive components are reacted with alkalis, expansion and cracking will also occur. Furthermore, I continued with learning the tests of the ASR, the ASR, and how this can be tested and the different types of methods we can use. Lastly, I finished my aggregates part of this learning experience by understanding the harmful materials in fact that can be found in aggregates, which can be divided into three materials, these being the organic impurities, decoating, and these unsound materials. Furthermore, I went into details about each one of these impurities or each one of these lecherous materials, and I finished my learning experience of aggregates. After that, after finishing from the aggregate, I went on to understand the second part of this learning experience, which is the concrete. I learned the definition of concrete and its usefulness and how we implement the concrete in our daily life. I also learned some of the advantages of concrete, these being the cast of any, these being the on-site fabrication is possible, or being durable and economically beneficial, as well as being having a high fire resistance and compressive strength. Furthermore, I went on to learning some of the properties of fresh concrete, which can be divided into four different parts. The first one being the workability, the second one showing very or no bleeding, the third one being the appropriate setting time and appropriate unit weight or the required unit weight. After knowing the properties of fresh concrete, I learned and understood workability, segregation, and bleeding respectively, and learning how to define each one of these, and learning the advantages and disadvantages of workability, segregation, and bleeding. Furthermore, after finishing from learning those properties, I went on to getting more details about workabilities and understanding the factors that could affect workabilities. These factors could be the water and cement context, the aggregate characteristics, the characteristics of chemical admixtures, and ambient conditions. I went on to each one of these factors and seeing how these factors can affect the concrete either positively or negatively. After finishing from and learning and understanding those factors, I went on to understand that workability can be measured by a test named it's called the slump test. I learned the slump test and understood its application, where it can be divided into three types: the stiff, the medium, and fluid. Each one have different sizes, or with first stiff being 0 to 2 inches, medium being from 2 to 5 inches, and fluid from 5 to 7 inches. I also went on to understand the unit weight in more details in concrete. After that, I went into the second part of concrete and the last part of this learning experience, which learns about the strength of hardened concrete and its different method applications, or how to tests of this strength. The strength of hardened concrete is the ability to resist strain or rupture induced by external forces. These forces or these stress can be divided into four parts: the compressive strength, the tensile strength, the bending strength, and the fatigue strength. There are some factors that these strengths are dependent on, which are the cement paste, the strength of the cement paste, the strength of aggregates, and the bond between the cement paste and the aggregates. Furthermore, I went on to understand the factors or the properties that can affect the strength of concrete, which are as follows: the water-cement ratio, the quality of the mixing water, the properties of the cement, the properties of aggregates, the mixing, transportation, and the curing condition or the age of concrete. I went on to details about each one and how this can affect the strength of the strength of the concrete. First one being the effect of water ratio, where the increase of water cement ratio can cause a decrease in the compressive strength. A good quality of mixing water is needed for a good strength of concrete. Adequate transportation is needed, where improper transportation or improper placing may lead to segregation. And lastly, the satisfactory an adequate amount of or the adequate temperature is needed, which is about the 15 to 16 Celsius degree, where a higher temperature than that can decrease the strength, and the lower than 10% Celsius temperature can decrease the hydration rate, where a temperature of about 0 Celsius can slow down the hydration of the concrete, leading to a decrease in strength. After getting understanding these factors, I went on to understand the various methods of homogeneous curing, which can be divided into two types, which are the water curing and the seed curing. I learned the definition and understanding of the application of these methods respectively. Furthermore, I went on to understand the compressive strength of concrete, which is employed primarily to resist compressive strengths, and the calculations for these strengths, compressive strengths, are usually based on the compressive strength of the concrete. Furthermore, I went on to understand the three different types of tests that are used for determining the compressive strength of concrete, which are the standard test specimen, the drilling course, and the estimation of compressive strengths. I learned each one of these strength tests in details and learned their applications and their different methods on how to calculate the compressive strengths in each of these tests. Lastly, I ended my learning experience by understanding the determination of splitting tensile strength and the determination of flexural strength of concrete, where in concrete there isn't a specified tensile strength test. Thus, we are using the splitting tensile stress of concrete and the flexural, and for the application of flexing the strength, we use the flexural strength of concrete test. Thank you, Hojam. This is I ended my learning experience, and thank you.